Hi everyone, and welcome back. For this video, I tested a hierarchical crew with different LLM backends locally and in the cloud, both free and paid ones. I will fully walk you through how to set up the crew, set up your environment, and change the LLM so that really everyone can follow along. At the end of the video, I will show you how all the LLMs compare in terms of quality of the results, runtime, and cost, so you don't have to rack up a huge bill testing all of them like me. Spoiler alert, I had some of the best results with a completely free setup. The LLMs I tested were OpenAI's GPT 3.5 Turbo, GPT4 Turbo, and the new GPT4o. I also tested Groq with Meta's new Llama 3 model and Mixtral, as well as running Llama 3 locally on my own computer using Ollama. I think the results were really insightful and exciting. I will first give you a quick review of all the technologies involved. Then I will walk you through how to clone the crewai-examples repository and change it for our purposes. I will then also do environment setup with you and install all the components needed for all the technologies we will use and show you how to get the API keys you need. We will then run the same crew setup with different LLMs, and in the end, look at a comparison table for the different LLM setups in terms of quality, runtime, and cost. LLMs, or large language models, are pre-trained language models that allow computers to generate natural language and interact with humans in the form of chatbots like ChatGPT. As powerful as chatbots like ChatGPT are, they have severe limitations when it comes to creativity, multitasking, access to real-time info from the web, and non-language related tasks. AI agents allow for a more real-time interaction with these models and for the usage of specific tools like access to online search, emails, and anything else that can be automated via APIs. AI agent crews like CrewAI take this concept to the next level by allowing several LLM-powered AI agents to collaborate on a larger project and producing really mind-blowing human-level results for a fraction of the time and cost of a human team, sometimes completely for free. For a more detailed description of CrewAI, take a look at my earlier videos on this channel. My most recent video on CrewAI covers almost the exact same crew setup we will be using in this video, so that might be good to watch if you want to understand the crew setup itself. If you want to learn more about what CrewAI itself and what it can do, check out my first video on CrewAI. LLMs are trained on huge datasets of text and are getting better every day. Since ChatGPT first came out, we have seen the emergence of first GPT 3.5, then GPT4, and more recently the mind-blowing reveal of GPT4o by OpenAI. Facebook's Meta has worked on their own open source LLM called Llama, with the recently released version Llama 3. Meta's own testing shows that the 70 billion parameter version of Llama 3 beats Gemini and Claude in most benchmarks. It's still a much smaller model than GPT, but as we will see, it doesn't perform so poorly with CrewAI, and since it is open source, it is completely free to use either via the cloud using Groq or on your own computer using Ollama. Ollama is a tool that makes it super easy to run all kinds of open source LLMs on your own computer, depending on what your computer can handle. So basically you can just have a chatbot similar to ChatGPT on your computer for free without needing access to the internet or anything else. Groq is an AI company that developed a new type of chip they call an LPU, or language processing unit, specifically designed with LLMs in mind, allowing it to be 25 times faster than GPU-based systems like ChatGPT. More importantly, Groq allows you to run large open source LLMs like Llama 3 and Mixtral completely for free using their Groq playground. Groq with a Q is not to be confused with Groq with a K, which is Twitter's chatbot and was created a long time after Groq with a Q. Here's an article of the company making fun of Elon Musk for apparently stealing their name. The last LLM we tested was Mixtral, which is an LLM by the AI company Mistral AI that is also open source and is supposed to outperform Llama 2 and GPT 3.5 on most benchmarks. Okay, so this time I really want to show you step by step everything I'm doing so everyone can really follow along, but I'll do it quickly. So first of all, you're going to go to Joao Moura's crewai-examples directory and you're going to copy the URL for the directory. Then you're going to your command line and you're going to do git clone and paste the URL of the repo. And then you have your crewai-examples. So what I'm going to do, I'm going to go in there. And we're going to work with the Instagram post repo and change it to do what we want it to do. Okay, so let's actually open this directory with VS Code. So we're going to do code Instagram post. And in here, we're going to change all the files that we want to change to make this crew a little bit more simple to then try out different LLM backends with this new crew. Okay, so the first thing we're going to do after opening the code is going to main.py and remove anything that we don't want the crew to do. So basically, because there's two crews involved here, we're going to remove the second crew because it's going to take more time if we run 2 crews. So we're going to just run the add copy crew. This is the first part, and remove everything after line 46. So we're going to remove all of this, not everything. We're going to remove the photography crew and everything related to the image. If you want a little description on what these crews do, go to my last video on using CrewAI to automate Instagram posts. So this is what we're going to do, just without the images. So this is the first thing. And our default baseline LLM is going to be GPT 3.5 Turbo. And then we're going to compare all the other LLMs to it, because that's the one we used in the last video. So what we're going to do is, to the crew, we're going to add these 3 lines. So we're going to define the process as being a hierarchical process. We're going to make the manager LLM chat OpenAI GPT-3 Turbo. So this is the model we're going to use. We're going to use a temperature of 0 to be giving very consistent results and not be very creative. And hopefully this will give us the best comparison across models. And we're going to set memory to 2. For this to work, we need to import chat OpenAI and process from CrewAI. So that's what we're going to do now. So from CrewAI, we're going to import agent and crew, but also process now to be able to use the hierarchical process. And we're going to add the following line from LangChain OpenAI, import chat OpenAI, which is going to be used to create the 3.5 Turbo LLM object, which we're using here. So now we're going to go to the agents file, and in the beginning of the agents file, we're going to add a few lines. So we're going to add the line from crewai tools.tools, import the website search tool and the SERPDEF tool. And then we're going to instantiate the web search tool and the SERPDEF tool, which I preferred over the scrape and summarize and search internet tools from the browser tools and the search tools that are defined in this repo. But these come out of the box, so there's no need for you to do anything else except import them. And then we also have the line, so this is now the same line as here. So we also have the line from LangChain OpenAI import chat OpenAI, which similarly to just before allows us to create the chat OpenAI object that will be our LLM to do the work for the agent. So the agent's LLM will be 3.5 Turbo again as our baseline model, and later on we're going to switch it out with other LLMs to compare. So you see these squiggly lines because currently in this environment CrewAI tools is not installed, so make sure it's installed. We'll get to what you need to install and set up for the environment a little bit later. But for now, what we're going to do is we're going to replace these tools provided for the different agents, and we're going to replace the LLM for the different agents. So here, all we're going to do is remove this, or comment it out if you want, and replace it with agent LLM, and later we're going to change it to be different LLMs. So, but we defined it up here to be GPT 3.5 Turbo. That's what's going to be used for all the agents, but technically you can change it for the different agents. So each agent can have their own LLM according to your needs. But right now we're using this LLM for all these agents. As you can see, self LLM, it's just the LLM that is defined up here, but it could be different LLMs. And we're going to remove all the photography stuff because we don't need it today. And now we're going to replace the tools as I mentioned. So we're going to use the web search tool and the SERPDEF tool for the product competitor agent. Remove these two, which I didn't like how they behaved. So let's remove them. And we're going to also use the web search tool for the other two agents. So let's copy this and replace the scrape and summarize tool. The search tools, search internet and search Instagram work just fine. So I'll leave those. Those are predefined in the tools folder here, and same here. We're going to get rid of the scrape and summarize website browser tool, but feel free to play around with the browser tool as well, as it comes with the crewai-examples that you just cloned, so you can figure it out for yourself. And the only other thing I want to change is adding 2 lines to each agent. One is max iteration 4. This again is to keep the work of the agents short and not go into endless loops, especially for the weaker LLMs. That's going to be important. to be able to compare the different LLMs as well and allow delegation. So this will allow the agents to pass tasks to each other. And we're going to add it for the other two as well. And that should be it for agents.py. Now, because we're going to use the latest version of crewai that also has the hierarchical crews, we need to also change a few things in tasks.py. Namely, we need to provide an expected output, which crewai now expects. So you need to add the line expected output equals, and then put a description of the expected output that you're going to have for each of the tasks. And this is what it looks like. So here in this case, I have a product description listing the features, benefits, and key selling points of the product. The report should also address market appeal and suggestions for enhancement or positioning. So I literally just copied it out of the task description, but be as specific as you want to be, and obviously change the text for the task description as well. And now do the same for the other tasks. And we can again remove the photography related tasks. So I went ahead and added the expected outputs for all the different tasks. So you can look at them here. A list of top 3 competitors of the company in question with a detailed comparison between our company and the competitors, but you can be much more clever with the description here. Campaign development, a step-by-step campaign idea for Instagram. And the Instagram ad copy task has an expected output that is a list of 3 possible Instagram ad copy posts. The only other thing that I've included last time was the sentence, please perform any online search just once. So I added it to all of the tasks. The reason being that for some of the LLMs that I tried, it was actually performing several searches more than once, and it just took forever. I don't think that would be a problem for GPT, but I'm adding it anyway to restrain the agents with the weaker LLMs a little bit, not to do too many searches when not necessary. So the next thing we're going to do is set up the environment for our crew. And luckily, when you clone the repository, it came with a pyproject.toml file and a poetry.log file. And if you are going to use Poetry, this will make it very easy to install most of the dependencies. We will have to make some fixes, but it will install most of the dependencies, and we can fix the things we need to fix manually, and Poetry will take care of documenting it in the pyproject.toml file. So because we have a poetry.log file, Poetry will know to install the exact versions specified in this file, and all we have to do is go to the command line. And first of all, if you don't have Poetry, you need to install Poetry by doing pip install Poetry. But I already have it installed, so nothing new will have been installed. And so we're here with the Poetry log file and the pyproject.toml file, and all we need to do is type Poetry install. And in my case, I found out that I'm currently using a Python version that is not compatible with the requirements in the poetry.log file. So what I'm going to do is activate a Python version that is compatible. So in my case, I'm using pyenv for this. And as you can see, I have these versions available, 3.9, 3.11, 3.12.2. And what we need is anything above 3.10 and below 3.12. So in my case, if I'm using pyenv, I'm going to do pyenv local 3.11.8, and locally is going to use this version. And now I should be able to use Poetry install to install the dependencies, and now I'm not getting an error. So the only thing we want to change is the crewai line. So we want to add a line that specifies a newer version of crewai. So version 30.11 is the latest version of crewai. So that's what we're going to use. We're going to remove the original line, and we're going to include the extras tools because we're using it for some of the tools that our agents need. And now let's save this file. And on the command line, run poetry update. And as you can see now, it installed CrewAI tools and it updated CrewAI from version 11.2 to version 30.11, which is exactly what we wanted. So the last thing you need to do is go to your env file and add your serperdev API key and your OpenAI API key. You can remove these two lines. The OpenAI API key without the underscore. Otherwise it's fine. And save the file as just .env, and then CrewAI will be able to use it. And now we can go to the shell and activate our poetry shell to activate the environment with all the dependencies that we need, and give it a first try at running our crew by typing python main.py and hitting enter. So of course I made a couple of mistakes. So I fixed some commas, and also I had allow delegation in there twice. So make sure the keywords are in there just once, and allow delegation was false for one of the agents. So I set it to true for all of the agents. And hopefully now we can run the crew. Also, in case these extra packages we don't need give you some problems, feel free to remove browser tools and load tools and OS and anything you don't need, and save the file, and then hopefully you won't run into any errors. So let's run the crew. And just like last time, I decided to, just for comparison purposes, use the Galaxy Watch 6 again. So let's copy the URL of the product page, go back to the command line, and paste the product website. Any extra details? Best travel watch in the world. Again, I have 0 relationships with Samsung or this watch. I don't own this watch. This is just to have a product that people know. And the crew gets going. Okay, so the crew has finished its job. This is the result. So there are 3 ad copies that you are provided with, and you can look at the log of everything that the crew has been doing. But what's interesting to us is the time it took, and then also the price. So just a little thing that I added that I didn't tell you guys yet is a snippet that gives me the time it took for the crew to finish its job. And I didn't want to sit there timing it with my phone. So all I did is imported the package time, defined a beginning time right before kicking off the crew. So just time.time, open parenthesis, close parenthesis. Then I run my job. So I kick off the crew, and at the end, I'm going to time it again. And at the very end, after posting the ad copy, I'm printing the difference of time of the computer from the end of the job to the beginning of the job. So the time in seconds it took the job to complete divided by 60. So I'll get the time in minutes. And that's what I get here. So it took 1.15 minutes to complete the job for ChatGPT 3.5 Turbo. So now we want to run it for GPT-4, which is much more expensive than GPT 3.5, but we want to look at the results and the cost in the end, and also the time it takes for the crew to complete their job. So we have 2 instances where we have to change the model. One is the manager LLM here. So here we can just change it to GPT-4 Turbo. And then also in agents, we have our agent LLM. And here again, we want to change it to GPT-4 Turbo. Save both files and run the job again. So back to the command line and run the crew. So I have to say, I'm somewhat surprised by the results of GPT-4 Turbo. So first of all, it took much longer than I thought. The crew took around 7 minutes to complete its job. So it took much longer than GPT 3.5 Turbo, which actually surprises me because I thought it would be more efficient at doing its job. However, I find the results to be much more on point. So let's look at the marketing strategy for GPT 3.5. So here's the step-by-step campaign idea for Instagram by GPT 3.5. Post 1 was an introduction to the Galaxy Watch 6, the ultimate travel companion, stay connected, track your health, and so on. Post 2 was about health and fitness. Post 3 about seamless connectivity. Post 4 about sleek design, and so on. And then I created the posts. However, for GPT4 Turbo, it did a lot more stuff. And actually, if you look at all the results, it goes much more into detail about the different posts and what the point is, what the image is. And I didn't even specify to create an image because I removed that crew, remember? But even so, it already thought about the image and it thought about the caption. It thought about the call to action. And in the final results, so it included calls to action, interactive elements. In some of the posts, it included polls. So I would say it's a more advanced team of agents. And that does make some sense. However, it's going to be much more expensive and will take longer to complete than GPT 3.5. So you have to kind of judge if you think 3.5 is good enough for your needs. And if, you can always run 3.5 cheaply. And then if it doesn't produce good results, you can always upgrade to GPT-4 and see if the results are better. But I'm actually fairly impressed by GPT-4's improvement over GPT 3.5. So now let's check out the new GPT4o. So just like before, we're going to go to our main.py file and change the crew to GPT4o. And we're going to do the same for agents. So here we're going to change it to 4o. And save both files. Make sure you save both files so you're not running a mix of different agent LLMs. Save and rerun the crew. So with GPT-4o as the manager, I actually ran into some trouble, and I'll explain more at the end of the video, but I decided to switch the manager LLM to 3.5 Turbo again and have just the agents use GPT-4o. So we just finished running the crew with the manager being 3.5 and the agents being 4o. So GPT 3.5 Turbo and agents being GPT 4o. And I really like the results. I think they're comparable to 4. I think, at this level, it's difficult to see what's better and what's worse. I think the posts look really good, and it was quite a bit faster than GPT-4 Turbo, which makes sense. And it also cost less, only 16 cents. So the next thing we wanted to try was using Groq with different LLMs. And I'm going to show you first how to set up Groq and get a Groq API key. So the first thing you want to do is head over to console.groq.com and log in with your email if you have an account. If not, you have to make an account. They will send you an email and then you have to click on the link in the email. You won't be able to create a password. So click on the link in the email. And then you are in the Groq playground. All you have to do now is, similarly to OpenAI, go to API keys here. Maybe you have to verify that you're human like me. And we're going to create a new API key. And we're going to call it YouTube tutorial. And remember that as on OpenAI, you won't be able to see this API key again. So copy it and store it somewhere. And now you are able to do Groq API calls. So the next thing we need to do is install Groq on the command line. So if we were using Poetry to install our dependencies, we can now do Poetry add LangChain Groq like this with a Q, not with a K. And now it's done, and we can very easily now use Groq instead of ChatGPT by changing our code. So let's go back to our main.py file, and the main thing we need to do is from LangChain Groq import chat Groq. So it's almost the same as what we had. And so it still doesn't recognize this because this file was opened not in the environment that has this has this module installed, but it will disappear once I activate the poetry shell. So we just imported ChatGroq from LangChain Groq, and the only thing we did was change chat OpenAI to ChatGroq. We kept the temperature at 0, and the model we're going to use for Groq is Llama3 with the 8 billion parameter version in this case as a baseline for Llama3, and then maybe we'll try the 72 billion parameter version after this. We're going to do the same thing for the agents file. So let's just copy this, go over to the agents file and paste it here. And then we can comment out the rest. And we have our agent LLM as ChatGroq Llama3 with temperature 0. We're going to save both files. Go back to the command line. Enter our poetry shell, and now we're going to run the crew again. Of course, I got an error because we had to import ChatGroq also in the agents py file and save it, and now we can run it again. So I want to show you real quick that the crew completely failed when using the Llama3 model with the 7 billion parameters. So this is when I was actually using GPT4o as the manager LLM, but the agents had Llama3 7 billion parameters, and it just didn't know how to use the tool. So it didn't understand what tool it was able to use and so on. And then in the previous one, I had tried to use the manager LLM also as being Llama3 with the 7 billion parameters, and it just didn't even know how to delegate the tasks. So this was pretty disappointing. So we now have the results for Groq using the Mixtral language model for the agents, but using GPT3.5 Turbo as the manager LLM. And results are okay. I think they're comparable with GPT3.5, probably, maybe a little bit worse. It took around 4 minutes, so that was definitely worse than GPT3.5. However, it was completely free, so that's definitely an upside. Now we're going to try and see if the 70 billion parameter model by Llama3 is going to perform better than the 7 billion parameter model, which hopefully it will. So all we're doing is replacing the model name now with the appropriate model name that we can find on Groq. So here you can see on the in the Groq documentation, the model ID, Llama3, 70 billion, and then these 4 digits. And I did this for the main.py manager LLM, as well as the agent LLM in the agents py file. And now let's run the crew again. So as you can see, I ran into some rate limit issues with Llama3, 70 billion parameters, and Groq when using Llama3 both for the manager LLM and the agent LLMs. So I decided to now switch the manager LLM to GPT 3.5 and have the agents use Llama3 and see if that works better. And it seems like this indeed has worked. We have a result after 2 and some minutes for GPT 3.5 as the manager and Llama3 70 billion as the agent LLMs. And the result looks fine, I would say. Comparable to 3.5 in general. I think I was more impressed with GPT4, but it was overall pretty good. And it was very quick. Here's the campaign steps. I think they're pretty good. Better than 3.5, I would say. Maybe worse than GPT4. But it was free, so I think this is a very, very good option. Now to run some of these open source models locally on your computer, at least, you know, the ones that your computer can handle, which is usually models up to maybe 7 or 8 billion parameters. If you have a regular private laptop like myself, you can download Ollama from ollama.com. So all you need to do is go to ollama.com, click on download. And then depending on your computer, you can do any of the following options, macOS, Linux, or Windows, and follow the instructions to install Ollama. I myself am on Linux, so my instructions will help most of you very little because most of you will not be using Linux. So just follow the instructions for macOS and or Windows, or Linux if you have Linux. So once you have Ollama installed, you can go to your command line and type Ollama, and it will show you the commands that are available for Ollama. So Ollama run will run a model of, a model you're interested in. Ollama pull will pull the model to your computer. So basically download the model to your computer. And Ollama list will tell you what models you have already available. So let's do that. I have OpenHermes available right now. So if I wanted to use Llama3, I would have to do Ollama pull Llama3. Or alternatively, I can just do Ollama run Llama3, and it will, before running Llama3, actually do the pull. So let's do that. So I have now downloaded Llama3, and I did this by doing Ollama run Llama3, which is the same as pull and then run. And now I am actually chatting with Llama3, so we can try it. Hey, can you tell me about yourself? So you can see it's typing, but it's typing very slowly. But it behaves just like ChatGPT would behave. So it's a large language model chat, and you can interact with it just like you do with ChatGPT. And Llama3 is supposed to be almost as powerful as ChatGPT. Just a note while it's responding, if you go to the Ollama website, you can click on models up here, and it will show you the available models. So Llama3 is what we're using right now, and we'll also try out Mixtral. But there's a bunch of other models like Llama2, which I don't suggest you use because it's just a weaker, older version of Llama3 by Meta. But there's a bunch of other models you can try out, but most of them will not be as powerful as ChatGPT or Llama3. So Llama3 is done responding, and this is what it looks like, but it took about a minute to respond, which I think is mostly because my computer is overwhelmed because I have a lot of things open. But it will work exactly like ChatGPT, except it's on your computer and it's completely free, which is nice. So to now use the local model, I have very little hope that the local LLM will perform well as a manager LLM. So the only thing I'm going to do is define the agent LLMs to be the local LLM. So for that, we need to go to the agents py file, import from LangChain's LLM Ollama. So from LangChain's LLM, import Ollama, and then define the agent LLM as such. Agent LLM equals Ollama, and then specify the model we want to use. So the model we want to use is Llama3, same as we just did on Groq. And then we can comment out this one and save the file, go back to our command line, and run our crew. So the local crew is now done. As a reminder, this was a crew with a ChatGPT 3.5 Turbo Manager, but the agents were all using local Llama3. And the results are pretty good. I think the results are slightly better than 3.5 or on par, but a little bit worse than GPT-4. However, it took 83 minutes to complete, so it's much, much slower than using ChatGPT and also slower than using Groq. However, it's completely free. So here are the final results. In terms of quality of the results, I think ChatGPT stays the clear winner, with GPT-4 and 4o being at the top, although GPT-4o had issues as a manager LLM. GPT-4 was much more expensive than 3.5, so there you have to decide if the slightly improved quality is worth paying 35 times more money. All of this is of course still cheaper than having a crew of humans do these tasks. Using a team of 4o agents with a 3.5 manager might be a good trade-off, as the quality was great, but the cost was only 16 cents. In general, I have found that mixing LLMs can be a good solution. It might even make sense to have different agents use different LLMs, with the more important task being performed by more powerful agents and the simple tasks by cheaper LLMs. I really liked using Groq. It was easy to use and much faster than running an open source LLM on your own machine. However, there are rate limits, so you would then have to see what works for you. The 8 billion parameter version of Meta's Llama 3 was a failure across the board. As a manager, it didn't know what to do, and the agents also had no clue how to use the proper tools. The 70 billion parameter version of Llama 3 performed much better, probably on par with GPT 3.5. But you might run into rate limit issues when using a crew that uses Llama 3 for both the manager and the agents. Using GPT 3.5 as the manager and Llama 3 for the agents is probably the best overall approach if you want to run the crew for free. The GPT manager should cost you 1 cent or less, while the agents are completely free with Groq. Mixtral also had surprisingly good results. When using a GPT 3.5 manager, however, I think there is very little reason not to use Llama 3 instead, unless you run into rate limit issues. Lastly, if you don't want to rely on any cloud LLM and not be limited by rate limits, or if Groq isn't free anymore in the future, running a local model with Llama 3 is an option if your computer is strong enough. Results were decent, but of course, given the computational limitations, the crew took forever to complete its job. So that's it, guys. If you want to learn more about CrewAI in general or the details about the Instagram crew we used here, check out my previous videos. I also have videos on how to get your OpenAI API key and how to clone a GitHub repository if you need help with that. Good luck automating and see you next time.